Okay, in this video we're going to be talking about section 5.6, which covers binary trees. So we are still dealing with trees, which, if you guys remember, a tree is a connected graph with no cycles. So let's kind of lay the foundation of what a binary tree is. The first thing is that it has to be a rooted tree. Okay, so this is a picture or a slide that we used in another lesson. So let me kind of edit this to where it's a little more user friendly for this particular type of uh, lesson. So okay, so we're going to take all the unrooted stuff out, and we're only going to be talking about a rooted tree because that's what a binary tree is. It must be a rooted tree. Okay, so moving on to our next slide here. A binary tree must be a rooted tree. So we have our root, and so we know that we have potentially a binary tree. Now the next thing is each vertex must have at most two children. Now, of course, we're using kind of a family tree type mentality here where um, think of this, let's see, think of like the root as a grandfather or maybe a great grandfather. You have vertex 7, vertex 5. These two are its children. And since we're dealing with two children, we know we potentially have a binary tree. So keeping that philosophy going, if we were to then look at vertex 7, we notice that it has two kids, which is 6 and 2. So that has two kids, but let's look at vertex 6. We're just examining the graph here. This has 5 and this has 11. These are the two kids of vertex 6. So everything on the left-hand side of the tree, each parent has no more than two kids. But let's look over here. You have vertex 5, who's the parent of vertex 9. There's only one child there. That's okay. And then you have vertex 4, which is the child of vertex 9. So all the parents have no more than two children. It is a binary tree. Okay. Now another thing that I kind of want you to look at is what would be considered the levels. Okay. Now the levels are kind of like generations if you kind of wanted to keep the family tree type terminology going. Okay, so each generation, so to speak, is a different level in the particular binary tree. So like, let me cut this out. So this is like the great grandfather. These are the grandfathers. These are the kids, and those are the children. See how I cut all that up into different levels or different generations, so to speak. So you would say that the very first generation um, of the tree, this would be level 0. Okay, and then of course as you build on, this would be level 1. This right here would be level 2. And then this right here would be level 3. So if I was to ask you what level is vertex 11 in, well, you would say it is level 3. Or what vertex is, I'm sorry, what level is vertex 7 in? I'll get it right, which is right here. You would say, oh, that's level 1 of the tree. All right, moving on. Okay, this is a binary tree. Just another example. Remember, guys, you can always pause the video or rewind it just in case if you need some extra instruction. All right, so here's my root. Let's look at all my parents, and all my parents have um, at most two kids. This is a binary tree. All right, moving on. Okay, this is not a binary tree. It still has a root, but now the next thing you need to look at is whether or not each parent has more or at most two kids. And if you notice, this parent right here has three children. So because of the fact that this child or this parent had three kids, um, it's not a binary tree. All right, moving on. All right, just more examples of what's a binary tree and what isn't. You can pause the video just in case you want to just go over it. So I'll give you a second. So pause it right now if you're going to. All right. So the answer to this is yes, this is a binary tree. This is not a binary tree because of the fact that this situation here, this parent has three kids. And I forgot to circle one kid. That's three kids. This actually can be considered a binary tree if you determine this to be a root. Okay, so I'm going to say this is a yes, but if this wasn't considered a root, then the answer would be no. But for right now, we're going to call this a yes. Okay, an expression tree. An expression tree is basically an expression that is in a tree format. Okay, you've seen this before in your everyday math class. And so what we're going to do is we're going to take that expression and then we are going to put it in a tree, which it is, and then we're just going to solve for it. Now, the way you do it is that if you're given your tree, which is right here, in order to solve for an expression tree, you are going to work from the leaves up to the root. So working with the leaves, if you remember, those are these things that I'm marking with the dash right here. And if you notice, all the parents have operations. So 2 plus 2 gives you 4. 2 plus 2 gives you 4 again, which 4 plus 4 gives you 8. And then 3 plus 3 gives you 6. And then 14 for your final answer. All right, let's try another one. All right, here's another one. Once again, feel free to pause the video right now if you want to work on it. Okay, this gives us 10 when you multiply by 8. That's a multiplication sign, just in case you guys forgot about that. That is 2, gives you a grand total of 78. All right, so that's binary trees. Remember, a binary tree, it has to be a rooted tree. It has to be a connected tree. Obviously, it has to be a connected graph with no cycles, and each parent has to have at most 2 kids. If you have any questions, let me know. Thank you.